Now let's look at something called cluster sampling. And what cluster sampling is, it's a cost-effective way to sample, because sometimes sampling can be very cumbersome. Why don't we start with an example to kind of illustrate this? Let's say we wanted to do a study on medical students, and we wanted to know if board scores correlate with match results, of getting the first results in their match. So the ideal thing would be to go to every medical school in the country. So I represented the medical schools here with a book with the rod of Asclepius in there and scattered around the country. Now this would be quite a cumbersome experiment to do because you'd have to go travel to every medical school, or you might email the dean's office of every school and try to get everyone's emails and getting them to answer, and that would just be quite expensive and time consuming. So what we could do instead is break them up into clusters. So a cluster is a group of people or subjects that have something in common, and yet the entire cluster is pretty representative of the population as a whole. So if we're interested in medical students, a good way to cluster is by medical school. So for a given medical school, let's say we chose this one. Maybe this one is UT Houston or Baylor or something in Texas. And all the medical students in there have some commonality in that they all go to the same medical school, right? And do they represent the population? Do all the students of this medical school probably look similar to this, look similar to all of them? Yeah, they do. Medical students in general are intelligent people. They probably have the same 50-50 male to female ratio, probably the same economic status diversity among them. So we could say we're going to make our clusters a medical school. That is what we're going to use as our cluster. So let's move this out of the way. This is our cluster. It's going to be a medical school. And now what we do is we randomly select from our group of clusters. We randomly select some clusters. So we'll pick here, let's pick UCSF. We'll take this one. Let's take Emory. Let's pick this one here. We're randomly picking these. Let's say that's Kansas. And you get the idea. You pick a number of clusters that you want to get. Let's say here we leave it at 3. And then you randomly select the clusters. So the first thing we have to do is identify what is a cluster. Then we're going to randomly pick clusters. And then within each cluster, we're going to examine everybody within that school. So we take everyone from UCSF, everyone from Emory, and everyone from Kansas, and then we collect the data we want from them. And so when we evaluate everybody from a given population, and the population here is our cluster, that's called taking a census, right? As like the census that we take nationally every year. So we randomly select our cluster, and then from each cluster we take everybody in there. So we take a census from within the cluster. So why did this save us any money? Because let's say we were going to do a simple random sample, then our sampling frame would have to be every single medical student in the country. So we would have to get a roster from every single medical school. We'd have to put them together, and we'd have to choose randomly from that gigantic list. Getting that roster would be expensive, it would be time consuming, and it might not even be possible sometimes. So what we've done instead is we've randomly selected a cluster. And then from within the cluster, we took everyone from in there. And so that saves us some time and money. Now let's just go over 2 more points. Do you have to take everybody from within the school? No, you don't have to. You could do a simple random sample here as well. So instead of evaluating all and doing a census, you instead of doing this, you could just take a sample, and it could be a simple random sample, or you could use one of whatever sampling methods that you wanted to. And so what this would be, this is technically called multi-stage sampling, because first you did a cluster, then you did a simple random sample. But you could do that. That's totally a valid way of doing it. So one last point we should make there. Let's take 2 more schools. The first is the University of Smarty Pants, and the second one is the University of Dummies. Now, you could rightfully make the argument that these 2 universities are not representative of the population. The people here are way smarter than the general population, and the people here are not as smart. They're below average. And so these are not representative. And so as being not representative, they don't make good clusters. And so then this would not be a valid sample. since even though they are homogeneous within their group, everyone at the University of Smarty Pants is highly intelligent and everyone at the University of Dummies is below average, but they are not representative of the entire population of medical students in the United States, so these are not good clusters. So what do you do in that case? Well, then, you might decide that you're going to make your clusters differently. Let's say we make them geographically. Like, say we'll take the West and Pacific Northwest schools. We'll take the New England Northeast schools. We'll take the Southern schools together. We'll take the Midwestern schools together. And so those are our clusters in this sense. And we see, there's a University of Smarty Pants in each one of those groups, and there's a University of Dummies in each one of those groups. And so those clusters are representative of the entire population. And so maybe that's a better way to form your clusters. So this is cluster sampling here. And remember, the way we do it is you got to form a cluster, you identify a cluster, and the people within the cluster should have some commonality. That's why they make the cluster, but they should also represent the entire population. Then you randomly pick the clusters. That's the point of the randomness here, is the cluster selection is random. And you can do one of two things after that point. You could take everybody out of the cluster and evaluate them. That's called a census, right? And that's one way of doing it. Or you could take a simple random sample out of each cluster as well. All right, so that's our cluster sampling video.